Scott, do you want something to drink? Quick. You can have mate or you can have one of these oolong teas.
I love it, oolong.
Oolong it is. All right. Great. And 3, 2, 1. We're live.
Hola. Hey.
Hola, ¿qué tal, amigo?
Bom dia.
It's been a long time since we've seen each other.
God, yeah, I haven't run into you for ages. Yeah.
It's about a year now. More than
Probably
that.
more, like, must be more, yeah.
More than that. Scott, good. Thanks for coming in.
Yeah, well,
really appreciate it.
Thank you for showing me your new space. It's cool.
Yeah. You came to the Yao Tong place.
When did he move?
Did you actually give a talk at the
I did,
Yao Tong place?
yeah.
That was on the genetics side. No, it was on the
I did the Bohinia project.
How's the status of that project now?
So, it did well actually. Like it achieved more than I thought it would because
Maybe you want to go into what that project
is
first.
I can. So, one of the many hats that I wear was trying to promote genetic literacy, and in the same way that kind of numerical literacy, computer literacy, 21st century, it's all going a bit kind of Blade Runner and the like, and we need to know how to deal with replicants and all of these kinds of things. We're just and this was before He Jiankui started CRISPRing babies and all of the stuff like this. But it's like we're trying to just promote to the public. You need to know more about this stuff, and loads of this stuff is going on in Hong Kong. Can talk about it more. But and so just as a way to kind of get people here involved, we did the first Hong Kong Community Genome Project. Hong Kong, we've got slightly messed up national identity. This weird emblem of a bizarre hybrid flower that shouldn't exist, and sort of mysteries where it came from. So okay, let's take all of these things together and basically do a kind of community genomic study to figure out where this thing came from. Show that DNA is not scary. It's not going to show the how expensive it costs, or like all of the steps, and then try and figure out the parentage of this bizarre thing. So we did a crowdfunding campaign, went to dim sum labs and kind of like load of public outreach, went on CNN, went on BBC World, went to M Labs, all of the top places to kind of
I love the way you said M Labs just after sort of BBC and whatnot.
to get interest in this, and so then we raise a bit of money, use that so no government money at all, sequenced that. We didn't have enough money to do the whole genomes, but we did the gene catalogs, right? We did the RNA, which should give enough to figure out the parentage of the Bohinia and some of its likely parents. So I think that was probably about the time that I saw you guys, and I think we'd probably just got the data. But then the next step was, and I was doing outreach and going to schools, secondary schools, middle schools. Even I think after I saw you, somebody gave me a load of 7-year-olds. I had this big gang of 7-year-olds. I was teach them about genetics. So I was like, okay, well we can make squishy DNA. And we smashed. They were very good at smashing up strawberries, and then we put cold alcohol and pulled out the DNA, and then I took them to do we can do phenotyping. So with this big gang of 7-year-old kids, we went out into the countryside and found Bohinia trees, and we were making notes this one has flowers, this one doesn't, and so it's outreach stuff. But the key thing was we got the data. Let's figure out the parentage. So we've got some master's students at Chinese U, and they basically assembled it, right? And they did it a bit embarrassingly quickly. We spent years getting all that stuff together, and then in a month they'd okay, yeah, we've done all of the analysis and it's finished, and it's we know the parents, and okay, it's kind of done. And then but it was cool. They kind of let their imagination run riot, and they were. The girl who was assembling it was really into Chinese medicine, and she was looking at historical genes, Chinese medicinal genes that may be related to Chinese medicine, and she looked in some of the old Chinese handbooks and oh no, they knew 1,000 years ago the Bohinia was medicinal, and stuff like this, and so it was cool. That's kind of where we got, and so the next step, well, we haven't really figured out a next step because they kind of did it. Then they tried to submit it to a scientific journal. Scientific journal rejected it because it wasn't like a massive study. But they wanted whole genomes and like, okay, get more data, and just like, well, this is all we could afford. So it's kind of been sat on a bit, but then there's a new student working on it at the moment, and they've managed to get these new nanopore sequencers that like fit in the palm of your hand and make super long reads, and so she is working on it at the moment. So like it kind of stopped, but stuff has carried on. So it was cool to see how it's going. Everything okay? Yeah. So that was the story so far on Bohinia, and it was what else happened? So it was all about getting a quite complex thing into the public eye, right? There isn't a Chinese David Attenborough. Like people, a lot of people may study. They're pushing STEM education and stuff, but they kind of like graduate and like, I'm just going to become a banker or work in Centerline like everybody else in Hong Kong. And like we were trying to encourage people, like there is a life outside of this. There's we can dive. We need to diversify from a completely like to a knowledge-based economy.
You should work for Edmunds.
New generation, M Labs, get the kids.
No, just can you reach over and give Sebastian a slap? For
Like,
no.
It's a welcome cameo. Like, this is.
He's like, you just like sort of like video bombed your Indaba.
But it's cameo.
Cameo. That's the one.
Like. Yeah, Hitchcock kind of just made a little
sort of like shuffled in on the screen and.
So we were trying to, get something into the public eye on top of like Carrie Lamina toilet paper and all of the things that the luxury goods and stuff that makes up most of the media here. And what was good was so. We got on CNN, we got on, BBC World, we got BBC Earth, we got, plant genetics on the front cover of the SCMP, which is like that was a success. We were contacted by Shenzhen TV, who were making a documentary for CCTV 9. So, like, Chinese state television was interested in this, and the show was on. So this was 2017, the 20th anniversary of the handover, and they were doing a science documentary series on collaborations between how Shenzhen and Hong Kong are working together 20 years on. So they filmed me, and they came in the lab and interviewed a lot of the scientists, and we said all of this like, this is a collaboration.
Nationalistic stuff.
This is
right?
we were kind of like, this is good stuff. We've Shenzhen and Hong Kong can work together, and we're using Shenzhen technology and getting the people of Hong Kong involved, and we're all trying to discover something about ourselves, and we did all this, and they're like, this is great, this is fantastic. They edited it, and then the week that they were going to show it. It got banned. So they broadcast the other 5 episodes, but not the Bohinia ended up like on the cutting room floor. It was censored because it wasn't. It was too pro Hong Kong and not pro Shenzhen. The whole thing is just like, we don't like it. It's not enough Shenzhen in this. So we were censored, but still like state TV was we got interest anyway from the mainland media, but what was weird was we got 0 Cantonese language coverage. That was the one thing that I was really disappointed about everything. Right, you can get on CNN, you can get like CCTV coming calling, but Apple Daily, Ming Pao, anyone we contacted in Hong Kong we made Cantonese language videos, resources. We had, I can't speak Cantonese, but we had like a whole team of local people who were very happy to do interviews and contacting people on our behalf, and like no one was interested. So that was, there was a lot of really cool stuff about it, but the one thing that I was really disappointed was like Cantonese media needed to up its game.
Yeah. It sounds like the state of affairs of science in Hong Kong generally, especially the funding, right? It's rather good if you compare that to Singapore. God, good grief.
Yeah.
You're working for Giga Science now.
Yeah.
BGI.
So I've been working for them for coming up to 10 years.
All
so
right.
the Behinia Genome, I do Open Data Hong Kong stuff. I've got this is like.
You're one of the founders of Open Data, aren't you?
I was there from the beginning. I wasn't technically a founder, but then I've been involved since pretty much the beginning.
Okay.
So from Behinia Genome, I've set up a NGO called Citizen Science Asia. For all of these various citizen science projects. If you guys have got any citizen science projects in M Labs, we're building a registry and trying to connect stuff across the region of Asia. There are associations in Europe, Australia, North America for kind of connecting and promoting citizen science. The UN is getting involved to use it as a way to fill in gaps in the, so like all of the sustainable development goals and everything. We need data, right? They're kind of metricizing things. They've got goals and targets, but professional scientists are only collecting a certain amount of data. We need citizens to fill gaps on studying biodiversity, environment, weather, climate, pollution, all of these kinds of things. Astronomy, all of the various things like this. And so they are promoting, they're trying to get like a global consortium together, but there's a big gap in Asia because, we're 60% of the world's population, loads of stuff like this. In terms of the biodiversity of the planet, we're like big biodiversity hotspot, but where you look at like where all of the biodiversity is measured, it's Europe, North America, like Australia, South Africa. You kind of the middle bits that are most biodiverse are the least studied, and we need people to like map this stuff in Asia. So anyway, so we set up this organization to fill that gap and kind of participate, and we submitted it to the Inland Revenue and everything. We had lawyers.
Hong Kong Inland Revenue.
So we're registering it as an NGO in Hong Kong.
Okay.
Submitted it in September 2018, and it was like 3 weeks ago we finally heard back saying, you can submit now.
For God's sake, bro.
Yeah.
For God's sake.
Yeah. So.
Why was it so slow?
Hong Kong, I don't know. We've had.
I mean, you can register a business within an afternoon.
Yeah.
But if it's an NGO,
there's a lot of politics about NGOs and things I think it was partly about. I think it was a bad time, with government shutting down, coronavirus, lots of various things like this, and then just in general, Hong Kong has certain crazy statistic like the most NGOs per capita or something in the world. It's been a place where there's been a lot of dodgy NGOs. But the government is really they're not even clamping down on the dodgy ones, but like just the whole NGO sector in general, there's a lot more scrutiny now. A lot of stuff that's been happening in the last 12 months. So I think we were just kind of, what we're doing is like very neutral, it's about as neutral as you can get, right? It's kids looking at animals and things like this. But even then, we've just been everything has slowed down a lot, and we were just hit by that. But anyway, we've passed, so we're now an NGO as well. But yeah, so these are all of the things I do outside of work. But my day job is Giga Science.
So before we go into Giga Science, you were mentioning this open data Hong Kong. Why create open? Why is open data important? Why have open data?
Good. Yeah, that's a very good question, and that Giga Science is around because of this question
because of
as
open
well.
Data. Okay.
Yeah. So we live in a there's all of this data is the new oil, blah 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 blah. Like we live in a very data centric world now. Like people are obsessed with data. The biggest businesses in the world are data. related, Silicon Valley, all of the but in the last couple of decades, there's been an increasing realization that proprietary data does, you can make money from this in certain ways, but data should be, there's a lot of stuff that should be for the public good, and it's much more efficient for society, and there's a lot of this data needs to be open, right? Things work better. Data sets that are siloized and not, things don't work if you've just got things in little closed off silos. To really, the dream is the matrix, right? But the matrix doesn't work if everything's in tiny little and so you need to connect it, and to connect it all, it needs to be open. We know within reason, within an ethical manner. You don't, and all of this, but ultimately, things need to be as open. Things should be as open as possible, and taxpayers fund for all of this stuff, pay for all of this stuff as well, right? So, our government, for example, we pay taxes. They do all of this stuff. They're doing it for us, right? We should own this. The lands department shouldn't be making money off our maps and
research and things like this. The government works much better if they open this stuff up. The government are, so this is Open Data Hong Kong is quite government data focused. We go into research data later, which I see as the same thing, because it's taxpayers fund this as well. But when people talk about open data, they usually talk about government data, and it's transport and maps and all of things like this. That the government. So the Hong Kong government are a great example in that they've been quite we can handle this, but they basically get a load of civil servants to try and do data science, and they're not the people to do it. So they built data repositories, but they've got stuff in PDFs and that's what I was going to say. It's you can go onto a typical website of the Hong Kong government. You can get information on it, but it's all published in freaking bloody PDFs. Yeah. What the hell are you going to do about that? And now recently they've introduced this like a capture code thing to be able to, so you can't scrape their website any longer. They're making it actively hostile for open data.
So, but then they also have one part of the government is supposed to be opening it up, but there's just no communication. So they have data.gov.hk. So they've launched the data repository where the stuff is supposed to be in, but only a small proportion of the stuff is in there, and it's not great. And so they've just had this mentality that people don't understand what to do with data. I've shouted at Fanny Law from Exco once at something. We released all. I was the civil servant. I was the person responsible for releasing all the census data, and nobody uses it. And then I was just what was the point? And it's just then I was just so wound up. I just stood up and started shouting because there's bloody PDFs and you can't use the stuff, and we've had a million hackathons and everybody pulls their hair out because it's so bloody unusable and things like this. So it's they thought, okay, we make it available. I've given you data now. Can you leave me alone and stuff? But it's no, we've spent all of this time. So the Hong Kong government had a competition. So this was 6 years ago, something we're gonna create apps and apps are the new thing. Everybody loves apps. Apps are the future. They did this competition where they were getting people to submit apps and all of these kinds of things, and then they contracted a load of apps. So they spent $10 million on 10 apps, right? And one of these apps was the Red Tide app, right? We get red tides every so often. So they spent 10 million divided by 10, right, on this Red Tide app. And then people came there was an article that a bunch of journalists came back and looked at this, 12 months later, it had 6 downloads, right? But they're civil servants, right? They're not. This isn't their job, right? They should just. So the open data movement is, you just make the data as usable as possible. Like focus on that, give it to us, and then
we will
yes, there's a million hackers who will make the coolest apps in the world, like based on this, and we'll do it much cheaper and much better, and come up with things that it's not your job. You're a civil servant. Like you're not Mr. App. You're not. Yeah. So everybody loves the example. Everybody uses is what's that? City Mapper, right? And things like that. Like these apps are brilliant.
Open street maps.
Yeah. Yeah. So the people who really close up a load of the data in Hong Kong are the lands department, because they actually sell mapping data, and so it's like the amount of revenue they're getting compared to everything that you could be doing, like the amount of time that every single person in Hong Kong is sat waiting at a bus stop because there's like 5 different bus apps and they don't work very well, and you can't plan your journeys because when you talk to the transport companies, they say, well, our bus drivers are uncomfortable, like sharing their locations and stuff. So we have to protect the identity of the bus drivers. We have to protect the bus drivers, right? And so there's 8 million people who waste an hour a day, like waiting for the bloody bus and stuff like this. But like the priority is, you gotta protect the bus drivers just in case.
Yeah, like in Helsinki, I remember waiting for a bus, and it was fantastic to see, like down to the second. Well,
even in Shenzhen, right? Even in Shenzhen,
yeah.
you just cross the border, and it's all like, if they're doing open data stuff better than Hong Kong, it's pretty embarrassing. But anyway, so open data Hong Kong has been kind of, this is the whole government data thing,
Right.
but there's been less focus on research data.
But this is the panacea. This is the sort of like, the new frontier. I mean, there's a whole bunch of stuff like open data, archive, these sorts of, and sci-hub.tw.
Yeah.
What a fantastic website that is. I mean, apparently she's been like sued now.
Big time. They wanna take her out. They wanna take her out. Yeah.
But I mean, that's. Oh, Sebastian, you headed out now. Okay, my man. Nice seeing you.
Final cameo.
Yeah, we should probably start the Indabas at like 7:45. This way, Sebastian can clear off and not interrupt all the. Here you go, buddy. Cheers, man.
Do you have a final message for the international community?
Do you have a final? No. He's had enough messages.
Okay.
Keys, buddy. The keys are on the table. Yeah, I know. Okay, so. Yeah, you're right. You're right, man. Yeah, serious stuff. We take security. We take physical security seriously around here. And the fob. Okay, buddy. Maybe you want the umbrella. Okay, man. Have a good one.
Please.
Okay, so open data Hong Kong. You guys have been chugging along for about
since 2013.
Yeah. 7 years. I was going to say 7 years now. 2000. Okay, so and has the government sort of like taken you seriously at all?
So there has been improvement. Like when we started, there wasn't even a data repository. So they got that, and then everything was in PDFs. And then we were like whinging about PDFs a lot. And then they suddenly, so then after like 5 years, and paying a load of money for a smart city blueprint to PwC, they paid them like millions and millions. So we're like, open data, you need to do this. Open data is important. But then ignore us. PwC pay them 12 million or something, and then PwC comes back. Open data is really important, and then they go, "Wow, open data is really important." And then,
my word.
Yeah. So
really, it sounds like the way to interface with the government is to be able to get one of these PwC cronies on your side, at least an important individual in there, and say, "Oh, we come representing PwC and open data, blah blah blah. Take us seriously." and then only then you'll be able to make traction
That's
in
Hong
this
Kong.
domain.
That's
It's
how
Hong Kong.
That's how it works.
Yeah, I know.
So then they eventually got it through that. Oh, PDFs are really bad. So they pulled off all of the PDFs off their website.
And of course, didn't replace it with the.
Well, so that we were tracking the number of data sets, and they were going up over time, and then suddenly they went down because they took all the PDF ones and didn't replace all of them. So they've replaced a lot of them, but it was like it's just kind of the way they. But then they put too many, like they've got so many different data types and things like that. They just need to be a bit consistent and stuff. But I don't know. So it's covered by the OGCIO, is the civil service body, the Office of the Government Chief Information Officer. And they're nice people. We've interacted with them and met them in meetings. But the thing is, it's part of the civil service that they have a high turnover of people. So you meet these people and they're like, oh, but it's just nobody's there for more than a couple of years, and then they just go on to another.
Surely one can create a set of like schemas that one can agree to. So even though there's churn on both sides, at least the schemas stay.
Yeah. So the one project that's launched that we've been working a bit with, the Hong Kong Open Data Index. So they just launched last month, and so that's the kind of thing they're trying to produce neutral best practice. So they're assessing the data situation every 12 months, and they'll do a yearly index and just go, this has improved, this hasn't improved, and then they give a set of recommendations, saying, look, this is an easy thing to fix, and this is, maybe use this schema and metadata standard and things like this. So that's a new thing, and stuff has actually happened in the last 2 years. So beginning of last 18 months actually, beginning of last year, they finally produced targets. So each government department has to do an open data, their own kind of report, like and kind of set targets. So like, but it's pretty random. It's pretty random. It's not very like smart targets, but they're at least doing a bit of transparency in this. And then after 26 years, they're finally updating the access to information policy. So Hong Kong is in a weird situation that this was one of the things that it's very British. Just okay, we're leaving now. Let's give them all of these. We don't have to deal with these stuff. So let's just give them a load of rights that we never gave them, just as we're going. So they did a code on access to information in 94, 95, which is a very early FOI. Like Bill Clinton only started talking about FOI in 94, and I think we got a legislation in 95. Though
FOI is freedom of information.
But they call it code on access. It's a code rather than a law, so it's not quite as binding as a. But they're still supposed to. They're still supposed to do this stuff. But the problem, one of the big problems with this was that it didn't. So we had a code that wasn't quite a law, but kind of like pseudo law, but then we don't actually have an archives law. So we're a very weird jurisdiction that that you're supposed to give stuff. You're supposed to share information with a certain amount of time, but you can also there's nothing to stop you destroying that information. Right. So all our archives are just like, it's not backed up by like every other place in the world. You have an archives law first, and then you have an FOI law. But it's Hong Kong, just throw random bits of legislation in. So and it's taken them all of this time, and 6-7 years. There was a government committee like, hey, we're gonna finally put in an archives law and turn the code into an actual law. And that disappeared into the long grass for almost more than half a decade. But finally, at the beginning of last year, they finally issued the public consultation on that, and it's just like, wow, it's going to happen! This is amazing. And then so we organized that. This was the last kind of big bunch of events we did at ODHK, was trying to get public feedback on this, and there were some things that were an improvement, some things were actually a step backward, because they wanted to introduce data access charges, right?
Oh, for God's sake. Jesus Christ. Oh.
So it's this is actually, we don't have many rights here, right? And this is one that they're actually going to change to like they actually have to now pay them for this nonsense. But this was one of the recommendations. So we're just like, this is, you know, don't put. I was trying to brand it as like, don't put in a data tax, right? You know, or like an information tax.
I mean, it's been funded by taxes in the first place. I mean,
and so few people
double
use this.
dipping, right?
So the actual amount of use of the code is like, it was something like a tenth of what they use in Ireland, right? And I don't think Ireland is famous for, you know, for being a very, well, I suppose they are getting.
I think Ireland is famous.
Ireland, yeah, actually, Ireland has changed.
At least for me, it is.
Yeah. But anyway, like, you know, but if you're like, Hong Kong praise itself as, you know, this kind of like Blade Runner skyline and stuff like this. But like, if you know, Craggy Island is beating us on data transparency and things like this, it's
it's shameful.
It is a bit, yeah. So anyway, but we pushed them on all of this stuff, and we were organising some meetings with Charles Mark and things like this, and then but then
how's Charles Mark? Is he actively helping push this thing forward?
Yeah, he's been the one person that, like, all of these things, he's been very useful,
right.
A lot of the we've not really done a lot in Open Data Hong Kong, but the few things we have, he was very. We would work with his assistants, and he would, you know, push some things in LegCo or like lobby that. So getting one of the few things we managed to do was they issue the budget every year, and the budget was just, they released it as a PDF, and there's a hell of a lot of information there. And so the data journalists at SCMP and all of every single year that the budget comes out, then they have to, you know, SCMP has to do like a nice glossy you know, like loads of graphs and charts and things of like, okay, we, you know, this is going up, this is going down and stuff. But they would get it like in this really annoying form, and the poor suckers would have to spend a day or two pulling the data out and putting it in a usable way, and then generating all of these. And they were just like, can you
give
just
us
give
a
us
JSON file or something?
Like even, and we figured out with all of this, that all of these PDFs, we figured that like these have been saved from Excel files. So like Excel isn't like the best thing, but could you not turn, because
give us the Excel file.
The secretaries and stuff who are doing this stuff, like, because their bosses want it printed out, so they're just thinking that everyone's like my boss, and they want us to turn it into a PDF so we can print it. But it's like, no,
just give us the Excel file.
Just give us the Excel file. And so like a few of us went in and talked to Charles Mark, and I think they were even like, some people were testifying in something in LegCo, or like just at least lobbying the finance, like I can't remember who issues the budget, which government department, but anyway, like talking to them and just like, this, can you just give us do it in a CSV or like something like this, and then they did. So that was, there's like little successes, but they have been good. But Charles was really helpful in like brokering this.
Okay, so he's a rather instrumental fellow.
So yeah. He understands technology, and like not a lot of them do.
Yeah.
I
would love to have him on at some point. At some point down the line, maybe he can come on, and it'd be great to chat with him. He seems like an interesting fellow. That one. So Giga Science is also sort of like an extension of this open data, or rather a specialization.
Yeah.
Is that correct?
So focused on research data, right? And so I've explained some of the frustrations with like government data and things like this, but like academia, when you really look at it, it's pretty dysfunctional. And
academia in Hong Kong or globally?
So globally, but Hong Kong is particularly,
especially so.
The people in their ivory towers and things like that. And so the way we do research, public funds it, researchers do it, and then the key thing is like they disseminate it. But the way they've been disseminating it effectively hasn't changed for 350 years. So they managed to update science once, but then they kind of, because pre-Newton and so people used to do their science, and then they used to write stuff down and then put it and lock it up, put it in a safe, and then basically then somebody else would, to claim priority, they would keep stuff secret, and then someone would say, "I've done this," and they're like, this was in my safe. I actually did it first. And it was just a really weird. That was like,
Right.
and then
There was proof of
350.
prior art.
But 350 years ago, they so the proceedings of the Royal Society, and Newton and I don't know, all of these kind of scientists of the day came up like, let's actually like write letters, and let's not do this like defaulting to shove stuff in a safe, but we actually communicate openly, and you claim priority by. And so, the world's first journal, Proceedings of the Royal Transactions of the Royal Society, was 350. When was that? 355 years or something like, and it was 66. So 354 years ago.
So how do you claim precedence in this scenario? Well, it's a centralized database essentially, so they probably timestamp it, and then you can say, oh well.
Yeah, well, they do a monthly issue of these letters that they would send around, and so you just kind of like so you just share these shared communal, and so then that's basically where the journal, the whole concept of the journal came from. And so for 350 years, everything has been focused on this is the I win. Okay, I wrote this down first, and I've got priority. But then standing on the shoulders of giants, you people can then build upon this stuff.
But as long as you cite it.
Yeah, so citation is a it's kind of a gentleman's agreement as well. It's not a legal thing. It's just but this whole concept of kind of scholarship came up, and it was I have to I don't have to credit your work, but if I don't, then that's bad bad play. You're a rotter and not a gentleman. And we will you won't be able to come to our club and smoke your cigars, and so basically this whole kind of system came out, and it was great, and it worked for 350 years. But now 350 years on, so everything's been focused on narrative, and but we're in this data-driven era now, and there's a great quote from what they called Donahoe and anyway, there's a great quote from the mid late 90s that publishing, right, these papers are basically advertising, right? You're advertising research, but the actual usable things that people need now in this kind of more data-driven era are the data and the software that kind of built this. And basically that stuff is not shared. Right? You don't get credit for that. You're getting credit for this narrative thing, but not for the stuff that we predominantly need now. And so basically this whole just the incentive systems are very focused on this. Have just got very, very focused on this certain thing, and so the way we do science, the way it is just focused now on writing a paper in in this kind of narrative way, and you need a story. It's not really, we do data, now we create data for the sake of data. You can do it like, so the Large Hadron Collider, like they wanted to answer one particular scientific question, but and Hubble and things like that, all right? You've got some scientific questions, but also you just want to create a shit ton of data. And you may not be able to, you've got some questions you may want to like ask it, but these big data sets, people will be able to answer questions that you haven't thought of, and you combine these data sets with other people's data sets in this whole big matrix, and then things that no human has thought of yet will just kind of come out of that, right? This is sort of data-driven science, right, rather than hypothesis-driven science, and people really need this data, but everybody's just very focused on this kind of like, I only get credit for doing this narrative thing. So science it's changed the way that we do science, and it's had some kind of bad bad consequences as a result.
In the sense that the identity of the researcher gets subsumed into this, like I mean, funding cycles are very
So
much about
there's publish and perish.
Exactly.
And so the thing that has really messed this up is so in the late 90s the Brits, those pesky Brits, they came up with this research, so the Research Excellence Framework, or the RAF, they keep changing the name, but they basically came up with a 7-year research assessment scheme. So we need, data is important, right? You need to, if you're spending a load of government money, you need to ensure that it's being spent in the right places, and someone's not pissing the money away. So they came up with this academic assessment exercise in the late 90s, and then we need what's a good way to assess researchers? All right, but so there's the publication output, and citations are there. So a scientist, you talked about credit, and so somebody writes a paper, and then if people build upon that research and they cite that, and so you get these kind of citation networks, and it is a way of saying, this is super highly cited, and nobody's ever cited this thing, so probably this research must have had potentially more impact than this one. But it's quite a kind of one dimension, it's useful data, but it's not the most sophisticated data, and at the time in the late 90s, they're saying, okay, how do we get this data? Oh, there's Thomson Reuters are selling this. They've got this special database called Web of Science, and so so this comes from ISI, and this guy called Eugene Garfield. So I don't know if you ever heard of Garfield, but in this whole kind of field, he's quite a seminal name. Only passed away a couple of years ago, nearly 100, super old. So in the 50s, he was studying. He basically invented the field of scientometrics, where he was studying he started this whole concept. Okay, yeah, some things get more citations than others. And he was studying in physics experiments in the 1950s and just looking at these half-lives of citation. So he came up with we can kind of metricize this. And then in 1961, I think, he basically set up an institute, the Institute of Scientometrics, ISI, that basically was working on this. And a few years after this, he came up with this index, and so I think it must have been books or something, they publish yearly books and just look at the citations of the journals at the time. And then in the early 90s, it basically went online and became Web of Science. And so he had this database and this institute and everything. And then in the early 90s, Thomson Reuters were they're just buying
Reuters at that time. Well,
yeah, actually, it would have been it would have been Reuters at the time. Thought, okay, this is they're starting to build these portfolios of products, and thought this is a useful one. So they purchased his research institute and just turned it into a product. I think he got quite a nice bit of money from this, and kind of, I don't know how involved he was after it became a commercial product. But anyway, it became this data source that you could use, and it kind of pootled along until the late 90s. The British government was like, this is the metric we're going to use. And so then when they did that, basically all hell broke loose. So publishing, there's always been prestige and there's the fancy journals and getting a good journal can make your career, right? The CNS, right? Science
Nature and Cell and like these kinds of ones. But if you looked at until I wasn't scientifically that active back in the day, but if you look at a lot of the seminal papers from Nobel Prize winning scientists and the like, a lot of it is in society journals, right? The societies have got these. This is where the really good quality, but like not super exciting. Like it's not the sexy research, but like they really like cross the I's and dot the T's or super stringent, and yeah. So the like this was, and if you're working a specific field, you've got the top journal in your field, and that's where you published. But then in the 90s, late 90s, it just this really turbocharged. So the UK introduced this, and then basically like loads of other, like pretty much every other country then followed. And the Hong Kong system is a complete clone of the UK ref. So all of the academics here get assessed on these 7-year cycles on impact and things like this. But the UK did a couple of cycles using this impact factor thing, and then realized like, Jesus Christ, we've created a monster. And so they've kind of downplayed this. But Hong Kong, we're like still like 2 cycles behind. So we're still but anyway, so that really turbocharged it. And so then in the 90s, everything flipped. That like, if I can get, there was a few journals that just had the highest impact factor, and so then suddenly like people then were like, my society journal, my field specific journal, it's kind of like mid-table, right? Because everybody in that field cites it, and this is the audience that should be, these are the people who need to read my paper. But if I get it in this like super sexy one, like, yeah, my field will probably read it, but no, it's not really as targeted. But basically, boom, I can like put my feet up and retire. And so that really flipped things to these, and it's a very interesting field in that. So, Proceedings of the Royal Society goes back 250 years. So the number one the New England Journal of Medicine launched in 1811 or something. It's over 200 years old. It's been the number one medical journal for 200 years. Nature launched like 150 years ago. It's been the number one biology journal for 150 years, right? It's this is a very, very static field. Like everything's set up to kind of maintain this status quo, and then this whole kind of flip to this one metric that rules all metrics. Then just really kind of created like an even bigger divide, right? It really just supercharged some journals, and everybody else kind of then struggled, and it led to a massive. So the profit margins as well of the publishers skyrocketed, right? It's not a massive industry, but it's probably the most profitable industry in the world. Mm-hmm. So the top so there's a few prestige journals, right? And then there's tens of thousands of other journals. But these big publishers, they're like, only a few people want all of this other stuff, but they basically then bundled everything. I want these few journals, but you have to buy this big package of everything. And the market really consolidated. The society presses, so many of them got merged and subsumed and taken over and then all of the various publishing houses have all just been acquired, and we're in a position where there's kind of like 5 just kind of mega publishers now, and then some societies and small but like everything is consolidating to like a very small number of publishers, and their the profit margins of the bigger ones, so Elsevier,
Elsevier just fell out with MIT recently.
So everybody hates Elsevier. Elsevier are the biggest and the least popular one, but they just own everything, right? And so you can't mess with them. And they're the ones who are like really trying to take out Alexandra Ectoban or whatever she is, the Sci-Hub and things like this, because their profit margins are 40%, right? So they're and you compare this to like tobacco industry, like oil, mineral. They are like double, triple the like what Rio Tinto make and something like this. It's the most profitable business in the world.
So it's a racket.
It's a racket,
But how is it a racket?
so and like academics have just given so these journals. So they charge. So if you want to read stuff, you have to pay. But then they don't pay the scientists give their work to them and sign over the rights, right? So they sign the copyright.
So this is
taxpayer
paid research, yeah.
Yeah, just to hand it over to most profitable companies in the world, and so then they own it's not even that the public owns it. You don't even own your own work. If you want to use your own figures in your teaching materials and stuff, you have to like then contact them. Hey, can I buy back the copy? Or if you're writing a book and then you want to reuse a figure you did from a pigget, you have to basically negotiate with this whole big sales team, and then buy your rights back to your own work.
Okay, so can we say academics are supposed to be the leading minds of the world, but actually they're stupid and think it's bullshit?
And so then the editors are, so if it's handled by academic editors, they work for free, or they may get like very small per diems or like things like this. So, but basically most of the editors are working for free, and then the key step is peer review, right? The reason we do all of this thing is historically like, okay, but then. But we've been publishing for 350 years, but peer review is actually a relatively new thing. They think it goes back to kind of this was all part of the whole package. But for example, Crick and Watson, right? That 1955 or whatever, that wasn't peer reviewed because it wasn't such a common practice then. But anyway, the key thing is this: this is what the publishers kind of justify what they do. We add value, and the key thing is we're this is the difference between the Sun and kind of this is peer reviewed research, right? We've got experts to look at this, but the experts aren't paid as well. Like this is all done for free. So everything is done for free, and then they charge huge amounts for the access, for these subscriptions, these packages. Since they've been doing these big deals, the price that they make from all of their subscriptions it's like way outpaced inflation and stuff like it's like crazy increases since the 90s, and universities just can't afford all of this stuff, and then even the rich universities can't afford it, everything. They can only afford a proportion. And so if you're in a developing country, if you are a patient and you want to I've got coronavirus, I want to read the research about this or something, Joe Public, you can't, even though you're a taxpayer and you paid for this, you can't access this stuff. But the scientists have given all of this stuff away because it's the way they get paid, right? It's become so tied into everybody's kind of joined into this system because all my research assessment is now based on these publications, and if I can get the dream is if I get this sexy publication, that's it, I've won. So people like it's,
you mean you get the research grants if you're able to publish in a good journal?
Yeah. And so you won't get tenure, you won't get your funding renewed, and the crazy thing is based on this. So this impact factor metric, right? So metrics, right? Okay, scientists are supposed to be scientists, right? Things. Okay, we've got like metrics are a scientific, can be this is a scientific way of assessing research. But what Web of Science does, which is the key metric that everybody's got obsessed with, it's a citation metric. So so it should be like number of papers. So you're assessing the journal, not the individual paper, and it should be like number of publications divided by the citations, right? That's a kind of fair metric, and it's kind of that. But
but this particular product there's two problems with it. So the first one is they count it over 2 years only. So it's a 2-year. It's based on 2 years of data, and what that means is.
Oh, for a field of mathematics, that's okay. Oh, sorry. Continue.
Yeah.
Continue.
Well, so
right,
fields
exactly.
where it takes a long time for payoff are then screwed, right? Because it's like, oh well, tough shit, you know. Yeah. And so basically, that all of the money then becomes focused on the things that get like short, you know, a short hit, and it's not even fields. It's just like, well, this is.
It's the equivalent of academic clickbait.
Exactly clickbait, right? It's basically turn academia to BuzzFeed or some kind. It's GIF bait, right? Journal impact factor bait, and so it doesn't matter in 2 years if like it's debunked. It's still they got the they're controversial. It's like these.
You want
life.
controversial.
You want controversial, right? Life on Mars. You want like arsenic life and things like this. This is good, right? It's as long as you can get through 2 years before the wheels fall off this thing, then that's perfect. And so particularly the top journals that are really the story their focus is sexy narrative, right? It's clickbait narrative that will get a lot of interest. So again, the narrative is like way outpaced the utility of the data. The narrative is now you want a really sexy narrative, and the top journals are the ones that are most focused on this. If you don't have an interesting narrative, this doesn't have the impact, right? There's the boring society journals that are focused on like boring things are true, right? But that doesn't get you promoted and stuff. It's the sexy but probably a bit shaky foundations, and so the whole system is incentivized bad research practice. So that's a big problem.
It comes to mind one particular paper I read about how somebody did some research about the orientation that a dog took its shit on the lawn.
Yeah.
And that's what the paper was about. Good God, man. And actually, recently do you follow Hacker News?
I've seen odd things.
Okay. So I think recently there's a publication about citations on Sci-Hub. So if you cite your paper on Sci-Hub, it seems to be a more accurate,
Yeah. Well, because the data that they're using for citations is proprietary, and it's the worst data you can get because you have no. And so the other flaw with that. So the flaw number one is it's short, and also so it's January to December, and so the journals know that if you publish something in December, because you collect 2 years, but if you publish in December, end of December, you're only really collecting 1 year. So they publish their shit papers in December, and they save the best papers for January. So you can see these trends they will hold the good things up. And so if you look at the medical journals, they always have a lot of journals have their December Christmas special with the wacky, stupid research. Oh, this is the dog taking a shit in a thing. And so that's probably a December paper, right? Because they were, yeah. And then, but the fact that like it's come to this that like that you'll get a dog taking a shit on December and like cure cancer on January. So
talk about perverse incentives,
yeah.
Right?
So that's pretty messed up. But then so they're using this proprietary data set, right? And so it should be number of papers divided by number of citations, right? The number of papers should be the denominator, but it's not, right? They have a negotiated denominator. So nobody knows how they negotiate them. But the top journals have all of these missing papers, and the higher the journal is, the more missing papers from the denominator. And so because they're flexible with certain types of content, they don't count in the denominator, but there's just all of these weird untransparent rules. So when they have all of the news and little news like commentary and things like this, this doesn't count in the denominator. And the top journals have more of this stuff, but for some reason, it just doesn't add up. Like, how did they get that denominator? But they do. But so that the system's pretty. This is not a scientific way. Like, doing it in a weird, untransparent. There's some weird handshakes in a smoky room that kind of has a massive impact on the number that basically determines scientists' lives. Is just insane to me. But everybody thinks nobody knows nobody knows these weird rules, and so it's just a very messed up
Only the
system.
select few probably know about them, and they're sort of incentivized to keep that system going.
Yeah, in a way, because even the publishing industry doesn't, like, you just, I don't know, it, like, none of this stuff is written down. It's just you kind of like. So the way journals are operating is they're trying to, like, influence this in some ways, but it's all, but like, nothing's written down, so it's all in hearsay. Like, oh, I think if you write something like this size, it may not count in the denominator, but I'm not sure, but like maybe, so just be careful, and there's all of this. So, but this is how this whole industry is operating. And then like UK messed this whole thing up. The whole of the world kind of got obsessed with this thing. Fast forward to mainland China.
Oh, they've taken it to the nth degree.
So they got so obsessed with this that basically the universities bid. So publication kind of equals money, right? In a you get your grants renewed. It's a bit, if you can get this top paper, it's not guaranteed, but you're probably sorted, and you're likely to get promotion and stuff like that. In US, Europe, and the like. China has it's like impact factor kind of is money, kind of, but it's in a sort of indirect way. In China, they've just done it. You get this impact factor, you get this much money. You get this impact factor, you get this much money, and to crazy amounts. So again, it's kind of a bit secretive here, but people have like crowdsourced a lot of this data, got things out. So on like Zhejiang University and some of the top universities were offering academics, if you get a Nature publication, you get nearly $50,000, 50,000 US.
Just for a one shot?
Yeah, just for being being the lead or corresponding author on these paper on a Nature paper, $50K in the bank, right? And the thing is, the salaries of academics in China are very poor, right? They got a lot of good. They've got all of these sea turtles that have kind of gone out.
They do a lot of business relationships and business and enterprises as well as with academia, because I know that this is what, when we went to Tsinghua University, a number of the professors that we were interfacing with did this sort of thing. They had something on the side as well as. Well,
you have to, because the salaries are so poor. So you either have to do something on the side, or you get your Nature paper, right? And they were doing stuff on the side because they weren't a first author on
their Nature paper.
They didn't get the 50K. Shenzhen, to an insane extent. So they have this Peacock 1,000 talent scheme. So it's based on your portfolio as a person, but they would bring young researchers back, and there's various criteria that you can get this scheme. But one of the things you can do is, like, if you have a Nature publication, they'll give you 3 million RMB. If you could, and like crazy amounts of money, and it's cash in your bank account, right? It's not to your university. It's not to. So He Jiankui, like, when everybody's like hand wringing, like, how did that kind of clones, the CRISPR babies and stuff, how did he do that himself? He's like, I didn't use any of my university funds for this. It was all my own money. Like, how does a 29-year-old, 30-year-old guy have access to that amount of money? It was from this bloody impact factor money he got from the Shenzhen government. Like, this is CRISPR baby money, right? Because it's just so untransparent. Where, like, because they just give you the cash and don't care what you do with it. Like, are you sure you're gonna give me like $500,000 US? Yeah, fine. Like, what are you gonna? I'm gonna CRISPR babies. Yeah. It's like, so. And so it's so much money involved, and it's so life and death, that so there's been cases in China that where so there was this like really cool, really courageous blogger kind of journalist guy throwing light on the like corruption in the academic system
In China.
in China.
Okay.
Academics who he was like pissed off paid some gangsters to try and kill him with a hammer. Right, so this impact factor thing's got so bad that people have literally been attacked with hammers because of it, right? Because it's so much money involved, and so then there's big money for the top publications and small amounts of money for and it's incentivized to you get impact you got impact factor 10 plus, Cell Nature Science, you get a certain amount of money. If you can get the journals that you publish in have to have an impact factor. You won't even graduate if you are in journals that are not indexed, and only a small proportion of journals are actually indexed. So they won't pass their PhDs, they won't be promoted, and so even if it's a useful journal, like you don't exist to them, and it's such a big deal to. It's life and death for these people. Like they can only make their career if they can do, and so it unfortunately leads people to desperation and attacking people with hammers in some cases. But the worst offenders are the medics. So
The medics.
Medics.
Medical field?
medical professionals in
sure.
China they got lots of money. A lot of them have a lot of money. They're crazy busy. And unfortunately, there's very little accountability and things like and the like. So they got a lot of money, but they can only get promoted if they get impact factor 1-2 publications, right? They're told that like you have to get a publication in an impact factor journal to get your promotion. But they're like really busy, and also they don't have the scientific background and stuff like this. So what it has led to is an entire industry of paper mills. So there's companies that openly advertise in China, and like I could show you some of these websites. I can show you. There's one. I haven't checked it for a few months, but I assume it's still up. 518.sci, and things like this. That they will openly and so basically, what impact factor do you want? And you
pay for that.
And you pay for that. It's just like, okay, so what field do you? What kind of rough area of research do you want? And you're gonna go, I'm a cancer doctor. I work in like pancreatic cancer. Okay, we'll get you so you pay us $10,000 as was been the going rate for an impact factor 1-2 journal and we guarantee money back in 12 months. We'll get you this publication or your money back. And so,
Scott, do you think this is where it sort of ties into the sort of international espionage that goes on between China exfiltrating research information from Western academics, etc.? Do you think that feeds into that paper mill?
I don't think so. Because it's just incompetent, right? You actually see this stuff and like it's.
Okay, you read this stuff and you just sort of burst out laughing.
It's just boring, and a lot of it is just. They make a lot of sloppy mistakes. Some of the people that have discovered this stuff have discovered it through typos. Like there's a database that doesn't actually exist, and then there's a researcher I really like in Spain. He saw this like, what the hell is this? This database doesn't actually exist, and then he then did some like data mining, and then he found like 40 papers. All that seemingly have no relation to each other, like from all over China, completely different subjects. They all mention this database that doesn't exist, and then he's just kind of looking at it, and then he realizes, oh, it's been ghost written, and then he had a Chinese colleague phoned one of these companies up, and then so multiple people have kind of come across. So it's now been exposed by various sources, but it was like a very dirty secret in the kind of publishing industry that there's just a lot. And so these paper mills, they write papers to order, and it's just they were doing like a common thing was meta-analysis. So
what is that?
Reanalyzing previous data, right? And so there was a very standard. So gene, like, there's 20,000 genes in the in the human, so they look at mutation in gene 1 in disease 2 or something, and then they would look at mutate and then and like analyze some of the literature. In some cases, just fake data and stuff like this. They kind of like have the hypothesis at the beginning and then just like generate a paper based on this, and they've just got just sweatshops of people just writing this, like, disease in gene 1, disease gene 2, disease gene 3, disease gene 4, every disease, every gene, just rewritten, and then just submit it to like every single impact factor 1 and 2 journal, and huge amount of it. So people have kind of caught wind of these meta-analysis papers are rubbish. So most of the journals have then like pushed up the thresholds for this, but then they just come up with new things like analyzing public data and for microarrays, and then stuff is just, some of the stuff is just outright fraud, because you'll see they've just recycled images from somebody else's paper and
not cited it or anything like that.
well, they just they say, oh yeah, we did. So I've seen some examples where it was like mouse xenografts or something. They give like some mouse model where they give them tumors and like inject some gene in, but and so they'd use just the same image, but say it was a different, like they had done this experiment and they'd added a different gene into the mouse or something.
Right.
And so just kind of, but some of the stuff is just really, really sloppy. But but the way they guarantee publication is peer review fraud. So people actually the big publishers found out about this through the fraud, not through these papers. So some people there's one guy who was really smart and found this through data mining and just seeing these weird trends in publications. But the main way that the publishers found this was they realized that there was fraud, and so fake referees, even identity theft of like editors and reviewers and the like. So they will suggest the standard one was they would suggest referees. And normally, if you were like a proper decent editor, you'd kind of like take it with a pinch of salt. That like, okay, they're suggesting them. You may want to check like, who are these people? Are they co-published? Are they? But then you may choose one to like help the process. But a lot of lazy editors are so busy they just automatically invite those suggested referees, and so they would just create charlesdarwin@gmail.com or something, like, just like either somebody or just somebody completely random, or like a real scientist, but just I didn't know George Church had a 163.com email address, but they just automatically invite that, and that was the but it just shows how shoddy the peer review process in so many journals is, that they just kept doing this. And then when it finally came to light, they would just go, oh yeah, this fake referee reviewed this and this and this, and then these like networks would just kind of fall apart, and they'd have mass retract. So every so often you see these mass retractions of papers in a publishing house will suddenly retract 100 papers and stuff, and that's because they've cracked one of these rings and things.
So well, it sounds like these publishing houses do actually have some sort of value, in the sense that they're trying to crack these.
A bit, but it's just kind of like,
I suppose that can be done with software, in a way. So, yeah, all right, okay.
So these are, I know, I'm just telling you a lot of the really shitty things about this shitty industry.
This is fantastic. I mean,
so,
getting the underbelly of what's going on in China. So I mean, okay, so you hear like, oh, China says, oh, we've published more papers than like, for example, the United States of America.
So this has been, so they've been on the verge of crossing the US in terms of numbers of publications for several years now. They're like right on the crossover point.
From the looks of it, it sounds like that all of those papers are, well, most of
those. Well, so
papers
not all
are,
like the medical like the standard of stuff in medicine is pretty poor. So there's some brilliant scientists, right? And like my host talk, and there is really good research there, but there's a lot of dross. And the yeah, they're publishing too much stuff because the incentive systems have just gone completely out of control. The amounts of money, the amount that's resting on getting this thing, whether it's real or not and fake, is huge.
Right.
And so the government just has the government has to completely reform the system because they've just messed everything up, like this whole thing. And so yeah, we get just we just get bombarded with Chinese papers because it's like worth so much to these people, and we have to, and it's sad, you just have to tell them no.
Yeah.
And then they'll like, they're like, my PhD student's not going to graduate unless he gets 5 publications and stuff like that. I feel really bad for them, but the government should never have set up. In my PhD, I published 2 papers, right? And I was lucky. A lot of people that don't publish any papers in their PhD. Like the way things were set up were just not having any. These bureaucrats set up these systems not actually understanding any of the consequences. It's just, metric is good, let's do this. They're doing this in the UK, so it must be a good thing. And then but then the amounts of money and then the lack of scrutiny and as well is just kind of.
How about the states? How is the system, while we're talking about broken systems, it might be a good idea to sort of like get a lay of the land of these broken systems across the world. How about the states? How is the states broken? Or are you more familiar with that? Or are you at all familiar? It's broken, not in the same way, but yeah, the whole system, they don't have the exact same system of payments based on impact factor and things like this, but the amount of power that the top PIs do in the top institutions, the amount of money that's just thrown on. There's I don't know if you ever see PhD comics. Yes.
But they keep their one of their classic ones is the prophecy scheme, where you've just got the pyramid with like all of the poor PhD students and postdocs kind of tricked to kind of like give their blood and sweat to just keep this very few people on the the people at the top of the tower. So it's very it's not really that different. The system is just messed up, and these incentive systems are just messed up. And so being a data person and interested in data, you get to so we have a pandemic now, and you get to like these. There's a whole system of incentives, and you get credit on the narrative and all of these things. And there's no incentive for the data, and the data has value. The data has a lot of value, so people don't want to give people a lot. The data wealthy academics do not want to give this up. And one really interesting thing. Working for my day job. Published by BGI, right? So it's a genomics organization. It came out with the Human Genome Project, and the Human Genome Project is a really interesting example where everything ended up in the public domain. It was this was a project for humanity. You shouldn't be able to own.
Wasn't Craig Venter involved in that?
Yes. So this is the Americans, right? This is the interesting thing that the America had gene patents.
Like that's a bit of a force of nature. Or maybe you can expand.
And so America, it was very interesting to see the difference between like Europe and the US on this project, in that. So it came out. It was originally funded. So the interesting thing that not a lot of people know about the Human Genome Project was it originally kicked off in Los Alamos, right? It was initially funded by the Department of Energy, and the reason that they were interested in it was Hiroshima. It was there was a pretty weird experiment went on that they like threw atomic bombs on people, and they were like kind of like then after the event like we should probably try and figure out what this actually did to these people. So that was the start of the Human Genome Project. It started off as a DOE thing, and then the National Institute for Health got involved after a few years, and then the two partners together carried it on, and it became a health project. But it's very interesting that its origins are actually like, Manhattan Project and kind of.
Well, if you wanna progress science, then start a war. It's a good way to get funding, right?
So it went, so it was publicly funded, and then and it became an international consortium, and it was it was like a moonshot kind of project, right? They ended up spending something like 10 billion or something, like massive thing, and so it's pootling along for a while, for like a decade or so. And they're doing everything very systematically and breaking bits up and I won't bore you with the techniques.
Do bore me.
So they're doing like physical mapping and really kind of trying to link it to like physical bits of chromosomes and things that they did this like very slowly and systematically.
This
and
is
then
using the shotgun technique.
No, that was before the shotgun technique. And then Craig Ventnor, who I think was in the NIH, he was just like, why are we wasting our time doing it in like such a slow, methodical way? People just want to know the genes. Drug companies just want to know the genes. So I've come up with this new technique powered by some cool algorithms, and he had like a very smart algorithm guy behind him. Let's just do shotgun, right? Can
you describe the shotgun technique?
Cut everything up into really small bits, and using some clever algorithms, just kind of sticking it together. And you may some of the order may be a bit wrong in the because there's repetitive bits of the genome that are going to be hard to assemble like that, but you get
good enough.
It's good enough to do most of the stuff that you want to do with it, and it's much quicker. And so at this meeting 2020, so this was this famous meeting at Cold Spring Harbor, where they have the Biology of Genomes conference every year, and they would meet and discuss how the Human Genome Project was coming. So Craig Ventnor then rocks up at the meeting one year, and he was saying, all right, so I'm doing shotgun. He basically, so all of the scientists were there, and I think he was in the NIH or something, and he left and went into the private sector. He turned up and saying, I'm going to complete it like so quickly that I'm going to be done before years before you guys. So you may as well not bother now. Like you should all stop and work on the mouse. It would be really useful if you guys work on the mouse, right? If you do the mouse genome, I'm going to finish the human genome. You're never going to catch me, and I'm going to own it for this private company anyway. But like, I'm going to let you use it and stuff like this. But it's fine. And then basically all of the American labs apparently were like, oh God. Like we can't
fuck this guy.
No, they were going to give up, right?
Oh, okay.
So all of the US researchers was
defeatists.
They were like, we've lost, and then there's no way we have the funding, the NIH, all of these people were about to like throw in the towel, literally this meeting. But then I don't know. So then they phoned up the Wellcome Trust in the UK. So in the 90s, the other interesting thing about the Human Genome Project was, it was the reason they managed to complete, the public people managed to complete it, was the AIDS crisis.
Okay.
So the Wellcome Trust, so it's a trust built on, so they had a kind of like a pharma company, and Henry Wellcome set this thing up like a century ago and put a huge amount of money, but they had
I wonder if Freddie Mercury, Queen, and Live Aid contributed towards.
Glaxo, the company that kind of came from the Wellcome Trust and then fed all the money back, fed loads of the money back, had all of the all of the decent antiretroviral patents. So at this point in the 90s, they were making shitloads of money. They were absolutely like just siphoning huge amounts of cash. And so the Wellcome Trust, so they found out the Wellcome Trust saying, look, we're gonna give up. And the American, and so then the funder of the Wellcome Trust jumped on a plane, flew to New York, and then so in the morning, basically everyone, like last day of the conference or something, everyone's just like, oh god, this is terrible. So then the Wellcome Trust guy came and just announced to everybody, we're not going to give up, right? We have more money than God, and if you all give up, give up. But we are going to do this in the UK, and they set up this big institute and say we can do. It doesn't matter how much it costs. We're going to spend everything on this to not allow it to
become a proprietary thing.
Become
right?
a proprietary thing.
Mm-hmm.
Like humankind should own this. And then the Americans then came back. Okay, yeah, I think we can do this now. I think we can do this. But apparently, the Americans were completely going to give up, and it was only the Wellcome Trust with all of it.
Who was that fellow that got on the flight? Do you remember his name?
Yeah, I know him. He's a really cool guy. What's his Michael Morgan.
Michael Morgan. So
Yeah.
a hat tip to Michael Morgan.
And also, the Wellcome Trust had set up this big institute, and the Sanger Institute in Cambridge, and Wellcome Trust was like throwing loads of money, building up this whole centre. And so John Sulston, who British researcher, was running this. So it was like Sulston and Michael Morgan were like, Sulston really hated Craig Ventnor. Like he was just we've got to get this guy. and so yeah, they upped the game. They kind of followed a similar approach, and it was a draw. So in the end, like Ventnor said, his version was a bit better quality or something, but they'd done enough public data. And released it that basically they killed Ventnor's business model because nobody was going to pay money when the public one was good enough. Yeah. So it was a draw, but in the end, the public kind of won. But it's interesting to see that the genes that Celera characterized first, they were all patented.
Celera?
So this was Ventnor's company.
Oh, Celera is Ventnor's company. Okay.
Yeah. But the ones that the Human Genome Project characterized first, and it's like interesting. People study the IP, like the IP and how much.
Sorry, I'm okay. So Celera found some genes, and what's special about this?
So it was just the 20,000 genes, right? Okay. And so it was a race to stick everything together, and then you annotate on the, and there's some that the private people kind of managed to like claim precedents and stuff for, and patented them, and have like monetized them, and so. But they've seen that like. There's people who have studied like how the difference on the amount of research and things that come out of like the private genes and the public genes. But like this is, you're asking what's the difference between America? Like they had gene patents that were illegal anywhere else, and so like the breast cancer genes. There was basically. What's her name? Mary Jean King or something? Oh no, this one group basically had pretty much discovered the breast cancer, like the two key familial breast cancer genes, but this Myriad Genetics, this American company, basically like they did this like really shortcutty kind of like and then but like patented them before. Just stuck patents on these two genes, and then basically own the. So in the US, you if you wanted to know if you had familial breast cancer, you'd have to pay $4,000 or something to get that information and stuff.
Yeah. Sounds like the rest of their medical system.
Yeah. So this is the difference, and then finally, like the Supreme Court overturned after 20 years, and they'd made a shitload of money from. Selling this information, they finally overturned it. So gene patents are technically not legal now, but they have all of that. They've got the biggest proprietary database of all of this stuff, and they're not giving that up. So this is still a problem that like still, if you want to know what your mutate, you can now you are legally allowed to know your own mutations. But if you want to actually put them in context, it's all in this. Most of the information's in this proprietary database that you still have to pay them to figure this out.
So surely there's an open database of.
There are open data, but it just they just managed to have. They had a 20-year head start, like collecting all of this stuff and keep.
So at least we can have a little bit of context to your own sort of genomic data.
Yeah. And this is just 2 genes, but like unfortunately they're the 2 most important ones for breast cancer. So this is just an example. But this is an example of like silo, data silo. Everything should be open, but people have monetized stuff in silos. But it's just people are dying because of this, right? People are, if you can, there's diseases that can be cured. There's people who are going to die who would survive if you can actually connect these pieces of information that are in silos. It like closed data kills people. So
rent seekers, man, rent seekers, silos.
Yeah.
Pays. Life is cheap. Life is cheap. It's the way it is.
And so so this is the kind of the thing that sort of drove us really. It's like breaking stuff out of silos and trying to incentivize. There haven't been incentives for opening stuff. So we launched this journal Giga Science specifically
to. So Giga.
Yeah.
Okay, now we've been chugging along for an hour and a half. I told you we'd go quickly, eh? Okay, so we've been chugging along for an hour and a half, and only now we're going to get into Giga Science.
Yeah.
So Giga Science is a journal.
It's a journal and it's a database.
Okay. Before we go into, if you could imagine what a healthily funded environment for science would look like, could you expand on that? What I mean, taking in all of this information of the siloed information and whatnot, how would you express what a healthy scientific research environment looks like, and compare it to like because as soon as you take that thing and you put it on the marketplace, it's gonna I don't think they're compatible. So in some senses, because
so they have it's healthier in Europe, for example, right? And then it's in North America, but like they have pretty free market in Europe. It's just they're not so focused on, and this is the nemesis of all. It's Bob Dole. Do you know the Bayh-Dole Act in like 1983 or something? So Bob Dole, the presidential candidate and stuff. One of his big legacies was this legislation in the early 80s that they passed in the US to monetize academic research, right? So universities can get more money, and all right, we've got to think of innovative ways,
all of these things.
So it pushes universities to get IP on the things that they discover, and so basically all of the big universities then got these technology transfer departments and units, and they became very focused on monetize.
Yeah, you say Europe is quite a good environment. I kind of firmly disagree with you in some senses, because if you look at lasers, the Germans are pretty good at it, but they've just got this very tight little circle jerk going on there in Germany, and if you want to get access to some of those top level lasers,
so where are the good lasers then?
Well, it's in Germany.
Yeah,
it's in Germany. But there's only very few companies that can do that, and to get access to that, it's just you're going to be paying a lot of money for it. So there's no way it's going to be open up, And there's these sort of like knowledge transfer kind of organizations.
So all universities have this now, but it was Bayh-Dole that was that drove this, and so everything was focused on IP, and so but then the whole open movement didn't really kick off until the 90s, with open source software, and then open data after this, and then open hardware after this. Right. And then they did realize that, like, okay, and there's a time and place for IP, right? There's a university can come up with a really cool thing, and it's a good source of revenue, and if it goes back, and it can help the university grow. But if everything is just focused on that, and there are some findings and things that like really benefit society, and also the vast majority of the stuff that they're sticking IP on, it's never going to make it anyway, right? When you're so focused on, so this is the metricization of science as well. Like, okay, you have to get this. We've come up with this stupid metric for pieces of paper, right? But then there's just you have to get 5 patents a year or something like that. So you just become a patent troll, right? And you're just patenting things for the sake of patenting things, and the patent goes on your CV, but it's like a completely useless thing that no one's ever going to do. But actually, if it may have had like a small impact if you just released it openly, but it's going to have zero impact now. You've shoved it in a silo just to put it on your stupid CV alongside these other stupid things.
And there's all sorts of little loopholes that you can work through. Like, for example, a spin-off company might say to the university, oh, well, okay, the university owns the source code of this. And then in the meantime, that spin-off company has found a source of revenue, or maybe a few cheap postgrad students, and they just rewrite the source code such that the university is not using any of the code the university actually had in the first place.
But publicly funded research, people have come round to, or at least in Europe, and Europe has a big open science policy, right? They've created this open science cloud, and all of these.
About Horizon 2020.
Horizon 2020 is just the European Union funding, the current European funding scheme, but they have EOSC, European Open Science Cloud, and they've got this whole bunch of policies that so they've come to the all right, we want to maximize the bang for our research buck. So there's if your IP, some money comes back to the academia, but that's not actually a very efficient way. We've got this certain budget, and they've come to the conclusion that open is to benefit society, for standing on the shoulders of giants. Like, everything happens much quicker if you're reducing friction, you're opening up these silos, linking stuff together. Just don't bother. Just make your software open source, make your data open.
One thing I quite like about this, I'm not sure if you're familiar with an operating system called NixOS, which is basically it's a declarative. Essentially, it's a distribution of Linux with a declarative package manager, meaning that you're able to execute a single command, and basically all the dependencies. It's a pinned universe of dependencies, and Horizon 2020 have an agreement with the Nixos Foundation, which says that anything that gets funded by this Horizon 2020, the Nixos Foundation will then package it.
Okay.
Which means that it's all open source software, and it's all reproducible. And having research that is entirely reproducible by a single command is to me, it's immensely valuable. It's immensely valuable.
So it's more effort to wrap this and do this stuff, but these are all of these things are work, right? It's more work to tidy up your code and to tidy up your data, curate it, follow some data standards, put it in a repository, package it, and data storage is expensive. All of these things have a cost. The good funders realize that we should work this into the cost of the actual, if the output is just this stupid narrative thing that no one's ever going to be able to use, then you need to change the incentive systems beyond this and so the funders are starting to realize, but academics just follow the money and follow the incentive systems, and unfortunately this is still the majority of the incentive systems. The only people that have the ability to change things are the research funders and the journals. So because we are one of the big, journals are one of the big carrots, and so this is Giga Science.
So
right?
this is Giga
we
Science.
are we're trying to be a tasty carrot that is rewarding people doing things a bit differently.
So ladies and gentlemen out there, if you want to get really good, bang for your buck, go publish on Giga Science.
Yeah.
Is that right?
Yeah, exactly.
So what is Giga Science? It's a
So
new
it's a journal and a database, right?
Okay.
So we give people that credit for sharing their data and their software and their reproducible other objects, right? The stuff that unfortunately it's more work, right? It's work and effort. So, and traditionally you wouldn't get any credit for this. People need this paper-shaped object that they understand on their CV and their funder understands, so we basically hijacked this stupid narrative thing, but it's just a wrapper for the data, right? So effectively you're sharing the data, but it looks like this. So we have a description, like a narrative description, push them to give a load of useful information, like I collected it like this, I've done some validation and shown that it works, but the key thing is there's a digital object identifier. There's a link at the end of the paper.
When you say digital object, is it cryptographic material?
So it's just a URI. It's just it's just a more stable URL, right?
Okay. So
we don't need to do crypto, it's open, right? It's just it's nice.
Okay. So
there are people playing around with.
Mm-hmm.
I've seen trying to throw blockchain
I'm
and stuff
stepping in
into
your way.
this.
You keep going. Keep going. Keep with your explanation.
There's some people who are seeing if blockchain is a nice way to track the provenance of all of these things. But
when I say cryptographic material, it doesn't necessarily mean blockchain. I mean, it could just be a signature of.
Yeah.
Okay. So you've got this.
And so it just links to the data repository that we've built, and we can store terabytes of data here. And this is the stuff that people want. So we have a team. We spend a lot of money, right? We've got a team of 3 curators who actually get their hands dirty organizing the data. We make a long-term commitment to the preservation. We're hosting this, and so we're piggybacking on. So yeah, we're piggybacking on BGI's infrastructure to store all of this stuff, right? It has a cost, but they've got supercomputers and all of this stuff. So
one of the most advanced.
We've got a lot of, and we thought, right, there's tens of. They basically wanted to have a journal, as a kind of prestige thing, and recruited me and a few other people 10 years ago to set this up. But there's tens of thousands of journals just doing this same stupid thing, and we are in an amazing position in that we've got they've got 1,000 bioinformaticians, they've got supercomputers, they've got all this stuff. So we were saying, let's focus on let's I had a bit of a chip on my shoulder as well. I was very pro open access and open data and things like this, and let's do things differently. Let's try and focus on the data rather than the stupid narrative. And so that's what we did. But we've made it simple enough, close enough to this thing that people get the credit from, that they can at least sort of understand. People will still understand it, but the key thing is.
What do you mean you've made it close enough?
So it's still we're a journal, right? Okay. We are technically a journal. We're indexed in these stupid repositories. We have the impact factor and all of those kinds of things that they still need for their CV. We hate all of this. But we've registered it and given that we refuse to list it on our website, and we've signed a declaration never to
list the people's repositories on your website. What do you mean list what on the website?
The impact factor, right? This Web of Science thing.
I see.
They're indexes that make our content more discoverable, but we don't brag about the thing that the people in China make money from and all of this kind of stuff.
Okay.
We're sort of playing the game a bit, but we do it to credit people a different way.
It's interesting you say this. I mean, the first thing that sort of comes to my mind is one of my favorite game developers. His name is Jonathan Blow, and I love playing his games. I really love them. And for the simple reason is that the way he looks at these games is completely different to the rest of, basically the rest of the world of game creation. And, you know, you would say, oh, I like the story because it's got a great storyline. He hates that sort of thing. The whole narrative, he hates it. So he's distilled these games down into the pure essence of essentially puzzle solving. So you're confronted with a problem in front of you, there's chaos, there's confusion, and then all of a sudden, after looking at it a little bit detail, and then suddenly you see insights, and then you see the solution, and then boom, there's like a sort of like a clarity and enlightenment that sort of happens. That's what his games revolve around. He stripped everything away except for just that sort of enlightenment thing. So essentially,
so we are
could we say that you've done something similar, that you just focus on the data?
We still have a bit narrative and stuff in there, but like we're minimizing, and like ultimately, I kind of, a bit in the back of my head, I'm a bit like, there's places for narrative. Maybe like, you know, you can have a TED talk or something every so often that like ties together all of these sort of. There's a sort of. But
stroke your ego.
Yeah, and like there are still stories to be told from, you know, in science, but so much of it is just shoehorned onto what essentially is just the data. So we're a bit kind of the anti-narrative journal in a way. Like we still do narrative, but. Be very the thing we really care about is the data, and so we've got this new project launching that's really taking things even more to the data, and even less narrative focus, and I can see so in our papers we go to the effort. So we're completely open access. Our corpus is completely open for data mining and stuff, and this is another thing that the like Elsevier and they're seeing. So there's this growing open access movement. There's a big push, and Sci-Hub and things like this are potentially driving this as well. That like people are not putting up with the fact that I paid for this stuff. In this day and age, how do we still have like these paywalls and things like this? You know, like
I have no problem.
Young people just can't understand paywalls at all. Like when
I
they
have no problem going to Sci-Hub whatsoever. None whatsoever.
Yeah.
Continue.
Yeah, well, like, all our stuff is open, so we like whether you know you can access it in Sci-Hub, you can access it from our homepage, but we deliberately make it at like machine readable. People can just pull it and do whatever they want with it, and so then, but also we're putting lots of various identifiers and things in to make it more machine readable as well, like basically and data mineable. So basically we want our stuff to be understood in the future. So much of stuff is going to be read by computers and not by humans, right? There's so much literature there that, you know, it's been people complain like, oh, there's so many papers, I can't read everything. You haven't been able to read everything for like decades, right? We're just in this big, you know, like what are they calling it?
Maelstrom.
Infodemic, like, you know, there's an infodemic.
Oh yeah, right. Infogeddon or something.
Yeah. So yeah, humans can't keep on top of this stuff. We're really focused on letting the machines understand and parse and combine all of this stuff. So this is sort of where.
Are people now using it, or are they already publishing stuff on it? Is it production ready?
So GigaByte. So we launched in 2012 with this main journal. It's hard at the beginning because what we were doing was quite different to other journals, and it's more work. Like, we're asking people to do a lot of extra, jump through a lot of extra hoops because it's the data, right? And if you want just some throwaway narrative thing, you've still got another, you know, in a world of 20,000 journals, there's another 19,999 that you can do this stuff. But we're just like, okay, we want to do something different. And so it was hard work at first getting, you have to, and you're not indexed initially, you don't have your impact factor, you don't have any of these things. So it's, the odds are against you, right? It's a system where the number one medical journal has been New England Journal of Medicine for 200 years. Everything is set up not to let young guns come in. But we're doing this stuff, and the old school scientists, they go, they do this, but there are a lot of people who are pissed off with the system. There's enough people that you start making a dent, start getting stuff. We slowly got indexed by these places, and so then it becomes suddenly, when we got indexed in Web of Science, the amount of and it takes, you need to collect over 2 years of data, and all of the stuff, and they gave us a pretty flat denominator, so if our first impact factor, if we in terms of numbers of, if we'd had if every journal had a flat denominator, in our first, without this like missing data and weird handshakes and something like this, our first impact factor, we would have had a higher number than the Lancet.
Wow.
So because like we've got really usable stuff, right? We've got it's not got sexy narrative, but actually when people cite our stuff, it's super usable. And so then people then like sort of started to notice and going, wow, okay, yeah, you guys have done it. And there's been a lot of copycat journals. A lot of the other big publishers have basically launched basically data journals now. So imitation is the most form of sincere form of flattery and the like. So we've done well, and so when we got the impact factor, our citations quadrupled overnight. Our submissions quadrupled overnight. So we're begging, stealing, and it's ridiculous. Like with the same journal, we were on June 29th, but on June 30th, because we got the impact factor, suddenly everybody wants to be your friend now. All of the people who are ignoring your emails for 3 years, suddenly like, hey, I met you at a conference last year. Hey, you're my mate. How's it going?
Suppressing the fuck off, buddy.
and then 0 Chinese submissions, and then overnight just boom, because you're worth a certain amount. We are a quartile one. We're in the top quartile, and so suddenly you become, and so. The Shenzhen funding scheme that that you could get $3 million if you publish in Nature. We were worth, if you had 3 papers in Giga Science, because you were Q1, you would be worth $1.5 million or something. Whoa. Like crazy. So suddenly like you become boom. Yeah.
So how do you feel about that? Having made several multi-millionaires over in China.
A bit dirty. So, but we want to we're pissed off with the system, right? It's complete nonsense. So, anyway, and so we're publishing like 150 papers a year, having to reject a lot more stuff now. We kind of and so our hosts organize. We sort of. You have to reject stuff. You have to reject stuff. You have to have some level of selection to.
Okay, this is another dimension.
Yeah.
You can have open publications.
Yeah.
But now we've got review. How are you handling the review?
This is hard with data. Oh. So the curators, we actually have full-time people on staff, 3 curators, data scientists, that we can get them to actually. So the curators curate every paper, and they're looking at the data and there's eyeballs there. There's odd papers that have these like workflow systems and stuff. We can throw our data science. It's a lot of work, but there's odd papers we get our data science in. But we do peer review the traditional way. We invite peer reviewers, but what the thing we do different from most journals is we won't send it to peer review until we have the data. So we've got a kind of system set up. We've got either they have it in a public repository already, or we have big FTP servers. So we spend a week or two like getting the data copied over onto our servers in Shenzhen, and then, or we can put them in AWS short term or something like this. And then when we have all of that, only then will we send it out to review. Every peer reviewer, we then saying, look, and here is the data. So whether they peer review that or not, it's because very few journals do this. And so peer reviewers are not really used to data, but we try to invite the more younger, hipper, data-y people. And we know that there are certain reviewers who are super stringent, and it may take them a bit longer, but they will actually like test the data. And but just the fact that the data is there, like whether or not they look at it, like the fact that that's still a step beyond any of these other things, that like at least the data was there. Another thing we do is open peer review. So traditionally it's been like an anonymous thing, but we actually, so one of the, like, we're not the first journal to do this, but like quite early on we were very pro. If you review for us, you actually have to sign this and put your name on this, and some people do find this uncomfortable. But actually, being the problem with peer review is, so there's the reviewer 3 syndrome, right? Reviewer 3 is like it's always that reviewer 3 is a complete bastard, and you don't know, is reviewer 3 like, are they actually, the author's always like, reviewer 3 is totally biased. It's that. Reviewer 3 is my nemesis. Why did you invite my nemesis to peer review this? But Reviewer 3 has all of the power, right? Because they are anonymous.
They're the decider.
They are, and so they may be completely unfair. They may be doing something completely unfair. But like a lot of the time, actually every time I've ever had when I was working on journals that were closed peer review, they're like, you invited my nemesis, you like bastard, I told you not to do that. But it's like when you know the names, and it's like that was the reviewer that you suggested. They always got everyone. But even then, even when you have closed peer review, they always think it's reviewer 3. But you can, like, it's often quite easy to guess who the reviewer is, just from the way they write, the questions they ask, or if you're in a small field, everybody you can kind of guess that anyway. Even when it's closed and you're protecting anonymity, it's not really that anonymous, right? But so anyway, we throw all of that out, and just you have to be open. So the authors know the reviewers know the authors, and so hopefully there's a lot more fairness in that, right? You're not having that douchey reviewer 3.
Do you have colluding?
So what do you mean by colluding, right? Because
if you know who your reviewer is,
yeah,
then I'll slide some mullah underneath the table to you.
So, but everything is transparent, right? And so if it passes review at the end, readers can take all of this stuff into account. And so, like, if there is just this really egregious, like, how the hell did this get published, and you kind of like the reviewers are kind of risking their own reputation if they do something like really kind of ridiculous. This whole kind of closed system is, you can get collusion, and even you can potentially guess who this person is, or there's all of the fake referees and things like that. Everything should either be, so a lot of people push double-blinded review as well. And I think the fairest things are, everything should be, because if the authors are not blinded, then
could you explain what double-blinded means for our audience who might not know?
So if it's single-blinded, right? You know who the authors are, but you don't know who the review. Like, so one party are anonymized and not the other party, but there's bias there, because it protect, like, the anonymous party can do what the hell they like, but then also they are swayed by and they know who the author is, even if it's blind. The reviewer can email their author and just go, hey,
give me, I
Go out for a night on the town. We'll
yeah.
Discuss later.
Yeah, so that there's no there isn't protection from that anyway. There isn't the. So if you blind the all, and also if like it's some big famous scientist on the obviously this is a good paper because it's like because it's somebody famous, and that
must be right.
And people are softer on the famous scientists, and if it's there are all these, this person's in India, it's a woman, there's all of these kinds of biases. So if you blind both parties, so you don't know who the author, the reviewers don't know who the author is, the author doesn't know who the reviewer is, that's super fair. Or you just do everything, everybody knows who everybody is, it's transparent, and you just take this into account. It may be right, it may be wrong, but at least when you read it, you can kind of like, okay, I know this reviewer, this is, and like, but the majority of the system is in this kind of like compromised half and half system. So anyway, so we've gone one way and do everything.
So you
do everything and it's also crediting it, like it is more work doing like peer reviewing data and things like this.
Yeah, that's
so
true.
we're actually giving them the credit, and so we actually give the reviewers. Each review gets a digital object identifier, so it's almost like a mini publication in itself, and you can cite the peer reviews, and the peer reviewers can stick this on their CVs and put it in their kind of online list of works and things like this, and so this is like another thing that we've been doing.
How does I always if you want to understand a system, know how the money flows. How does the money flow through this system?
So open access publishing has been a model for. So this is breaking the whole. So currently, publishing, and it was subscription based, right? You have to pay for libraries. The university libraries have to pay for a subscription, or you buy the individual articles for like $30. $100 in some cases, and the subscriptions are ridiculously pricey. So open access came along in the late 90s, where it changed the model that like somebody has to pay for it, but let's make the author pay rather than the readers, and so then it goes into the public domain like that. Basically, the cost goes at that at that point, and then it's basically in the public domain, and everyone can read it forevermore. And it can be hard for authors to have to pay for this. There are some people, Elsevier and the kind of closed access people who don't want their kind of model and revenue streams broken were like, oh, but pay to publish, and how is this this just means
what's pay to publish?
You like
pay to publish.
Pay to publish,
see.
right? So is this going to this? So what was thrown at open access was that there's just a big bias there. The open access publisher is just going to publish everything for the money. They've got no incentive to reject stuff. But it's not true. But if you are just publishing everything, then people can tell that, right? You can and you'll just kill your reputation. The way you are judged on these citation metrics and stuff. If you're just publishing rubbish, then no one will want to publish with you. So there's been there's been some very high quality, very selective open access journals. And the funders have basically been pushing this more and more and more because they realize there's more bang for your buck, right? They're funding this research, they want people to read it, and it is the costings are it's cheaper. So my previous job, the reason BGI recruited me and stuff to set up this journal, I worked with the first commercial open access publisher, Biomed Central, and they launched in 1999,
so the NIH and the European National Institute of Health, US funders tried to set up a kind of wanted to set up an open access, the first sort of open access journal and stuff, and they couldn't quite pull it off. And so this guy in the UK was like, I'm just going to do this as a business, and he had to put his own money in for 7 years, but then managed to make a profit. And then Springer, like the number 2 publisher, bought it out. Like after it made, he proved that open access could be profitable, but the margins are not it's not a 40% margin. It's like a 10% margin or something like. And so all of the calculations are that it's more cost effective. It's the funder is going to pay. It still has a cost, but it's not extortionate like this 40% profit margin.
So in Giga Science, the author is required to pay.
Yeah.
And the order of how much do they need to pay?
Our article processing charge is $2,000 about 2,000.
€2,000 and
2,000 US dollars.
What does that cover? I mean,
everything. So
the whole massaging of data, putting it into things,
and unlimited and hosting forevermore. Like we will.
But that doesn't seem to work, because I mean, you know, bandwidth is an ongoing thing, and it also can be pretty expensive. So it's like, you know, you're relying on other people's continuous payment to be able to pay for this dude's data dissemination 10 years ago.
So the with exponential growth in data, right? What was a lot of data 10 years ago is not so much now. There's that helps. So we've piggyback our storage and hosting is a lot cheaper because we're using our tens of terabytes of data is like very small potatoes in BGI's tens of petabytes of data.
Okay, so you're able to do this because you're able to piggyback on BGI's infrastructure.
And then and then a lot of the data does end. We don't necessarily have to host it. A lot of it ends up in. And we work with if there are public repositories for particular data sets that the government are funding, we help them get it into those, and so then we don't need to worry about. We just put the accession number in our paper, and the actual narrative part is that there's long running archives for that. So even if we fold, there are various archives that guarantee this narrative should be saved forevermore. So we piggyback on. There's a lot of infrastructure out there. It has a cost, but we pay those subscriptions up front, and then if we go down, for example, there's a dark archive called Clocks. That if any it's a dark archive.
What is it dark?
It's called apparently it's not public, right? It until something goes wrong, and then they host it between multiple universities around the world on their servers, and so then if a journal who's been paying the subscription to that goes bankrupt, then they basically will. It's a bit like the Internet Archive and stuff like this, but Internet Archive is available at all, like 24/7, right? But they only come on the scene when things go wrong, and then they just bring the content back.
So in this example, we've got a series of journals. They all get together in a gentleman's smoking room and say, okay, let's set up a place where we all put our stuff. We don't publish it open. If one of us goes under, that data is not lost.
Yeah, so this is what Clocks is. Clocks and locks. Lots of copies keep safe, and then Clocks is another anyway. So there is all of this infrastructure that we pay into and participate in if things go wrong.
Okay, so there's just an archival thing going on there. Okay, and okay, so this has been running for since 2013? Did you say?
Yes.
13 and
2012.
13.
And we've done well. So we have
turning a profit.
Not yet, but
the submissions come up, we get more revenue. The data side is expensive, and
Just data decide, you mean data dissemination or data?
yeah, having to pay for 3 curators and things like
I
this,
see.
that like the head count is higher. Like we're making a reasonable amount from the papers, but it doesn't quite cover all of the data side. But it's small money for BGI, and we're in the non-profit part of BGI, so we don't actually, we want to be sustainable, but we don't need to turn a big fat 40% profit margin like
Right,
certain,
like other journals.
yeah. But we've had to. The expensive thing has been the. So we've co-published with commercial publishers, right? To get set up, there are all of these handshakes and things that go on in dark, smoky rooms to be indexed and to be indexed is the key thing. There's publishing infrastructure, there's the databases you need to go in, there's marketing, there's things like this that are quite hard to do on your own. So we spent 5 years co-published by MedCentral, Springer open access publisher, and then we moved to Oxford University Press, who are the world's largest and possibly oldest. They or Cambridge University Press are like the oldest academic publishers, and so we basically contract with them, but the publishers and the infrastructure they use costs a lot of money. So this is why. So journals themselves do not make much money, but publishers make lots of money. So we're a journal, not a publisher. But what the next step and the infrastructure as well. So all of the publishing infrastructure, like it went web in the 1990s, but there's only a couple of platforms that everything is published on, and also so Elsevier and these sorts of and the publishers as well, as they see open access encroaching on their business models, they're changing their business model to get they realize that in the next decade or two they're going to be pushed out of the selling content market. So they are pivoting to the analytics and owning the infrastructure market.
So assisting the people to do their research?
So
providing like AWS kind of infrastructure with like standard libraries to be able to do transformation?
It would be nice if, so they're owning the publishing platforms, they're owning the preprint servers, and also they're preventing people data mining content, and they're trying to get as much build proprietary products built on all of the stuff that they're analyzing. They make, so Elsevier, they're the people really hate them, right? They are the in the whole open access movement, and like a decade and a half ago, like a decade ago, they were really trying to close down open access,
so they're
paying
Microsoft.
very aggressive lawyers and lobbying Congress and things like this. So they made a lot of enemies, and people don't like them. But their infrastructure actually works really well. Like they've got a lot of money, and they have very, very nice tools and everything. Their stuff actually works the best. And there's kind of open source options and like the hip young open access stuff. Their stuff doesn't work as well as but the infrastructure is horrible, right? The journals are charging very, very large amounts of money for all of this stuff, and they do a really crappy job. So it can take 2 months to typeset your articles. They make so many errors. And the software is so buggy that like everything is controlled by a couple of these publishing platforms. And if you want to change, the code base is like decades old. If you want to change anything, you have to pay them like $250,000, and like it's just insane. No other industry in the world would put up with the crap that the publishing industry does, but it's just there's not been any pressure on them to change, on
and there's such a small number of players involved that like everybody's just very happy with this. But there's a huge potential for this is an industry that like stuff has to change, and there's pressure from the funders and the public, and Sci-Hub throwing a hand grenade in and just kind of like there's a lot of stuff happening. So our hands have been a bit we've done a lot of cool stuff with Giga Science, but we're still stuck with this old-fashioned, very messed up publishing infrastructure. We have to pay the partners we work with the most of the money, right? So we're spending a lot of stuff, and we're giving most of the money away
The
to
archival stuff? I
um
mean, where's the money going to?
production, marketing, the typesetting, the
But why don't people...
platforms.
don't you use LaTeX?
Yes,
But
they pretend they use LaTeX, and they say we take LaTeX, and then people submit it, and then
doesn't compile.
yeah, so then they just throw it all away, and then they say, and then like rebuild the articles again from scratch, and things like this. When we actually look under the hood, you're just gonna go, oh goodness, this is horrendous. So anyway, so we've done really well, but our hands have been a bit tied in some things. So the next thing we're working on is our own infrastructure, or like new modern web literate, everything in XML. Screw, like if you want a PDF, okay, just generate that thing generate that thing at the end, but our readers are not like, maybe a very small number of people are going to want to print something out, but that's not our readership. Everything is focused on XML and interactive content. Like, why not have lots of plugins and this is the web now, right? This is everything. You should be able to interact with your stuff. So, and you can't do that with the current platform. So we've been working with a publisher.
Current Giga Science platform, you mean? Or
so we're collaborating with so they're not a publisher. They've come out of typesetting industry, but the founder, Carver Bazargan, is very funny that he says like, I should be out of business. He's got I've got a similar chip. Like, I think publishers should be out of business, and he thinks typesetters should be out of business. So we're sort of teaming up to like put all of ourselves out of business. So he's been going 20-30 years. He's a physicist. He's an optics guy, actually, a holographer, who got into LaTeX very early on, got in with Indians. So he's a Imperial graduate like myself in the UK, British Iranian like myself, and
so the two of you hit it off.
So he basically there's loads of fantastic like maths graduates in India, especially in South India, like himself, and so he basically built up a company getting like very well educated Indian science and maths graduates to basically, they had the best LaTeX, especially for equations and really complicated LaTeX in the business, automated more and more of it. They've got this fantastic compound in Kerala, this big eco-sustainable. They're doing really well in the whole coronavirus lockdown. That they especially Kerala's really sorted everything out as well. This compound, they grow their own food. They sort of do it. And so he's got loads of developers, and so working with him, basically built a platform from scratch that everything will run everything will run XML. It cuts out a lot of the really expensive, costly stages, but mostly like the production proofing typesetting. You're effectively just pushing a button.
And there may be a very small amount of human intervention, just that if the figures don't quite look perfect, a human may need to like tweak a couple of things, but effectively it's cutting out like a huge big part of the publication process, really massively reduce the time and cost, and doing everything, just throwing away all of this code base. So anyway, we're launching what we are calling GigaByte. So
it's a fusion of the two, or are you bringing in his work?
So we're using his platform, but our data, our expertise working with data, but all of the compromises that we've had to make on, we need to, we need to be very selective, and because our publisher wants us to be like highly ranked, and papers need to kind of look this way. Everything's focused on the PDF and things like that. We're kind of just throwing away loads of these preconceptions. Yes, things need to be like archivable in the long term. Yes, we'll have a PDF, but all of these interactive parts, then we'll just have like a little thumbnail in there and a link out to the dynamic parts, and everything will be focused on like the dynamic version, and more focused on smaller but useful data sets and code, and much cheaper, getting credit for things that you don't normally get credit for, interactive, bells and whistles and things that no other journal has, and doing everything in XML. We're breaking down other barriers, basically like you can just push a button and change the font to like for visually impaired people, dyslexics, change the language if you like, this is this is what we're launching in the next month or so.
That's terribly exciting.
Mm-hmm. That's what's been keeping us busy.
Yeah. And how does the money work with this system? You have to pay to. Is it a SaaS?
So again, we're like starting off with an article processing charge, but our costs are going to be much smaller. So we want it to be affordable. We want to break down the kind of affordability barrier. Work in and the beauty of XML, right? Having everything in XML is, and so also this is the way everything has been focused on, right? This narrative thing, and also proof. Version of record, right? And there's a lot of practices. The way you write a paper, it has to be it's the version of record, and it's a kind of like one-off story, right? And nothing can be, and basically it mustn't change, and it it has to be unique. But the way people do research now, it's much more like software development, right? Where you incrementally you just make iterative changes to things. Version 1, 1.1, 1.2, 1.3, and the same with data as well, right? You may create raw data, you may create a new version of it, you may process it and reanalyze, and you have these big consortia projects that are have just lots of incremental outputs. But in the traditional system, you would just get credit like once, or you got like your first. You have to like save up a load of things, and it takes a load of time, and there's no incentive to share the stuff before, and then you do and here's our big project, and then maybe it's ongoing, but you have to wait like 5 years, and then like here's our like updated project. But you want people to actually release the intermediate project and like
preferably the entire history.
Yeah, like the whole history, and the parts before that. Like, why sit on it until
So do you do it in the form of a Git repository or?
So we are looking at version control, really.
Yes.
And so we're looking at update paper. So this is we haven't quite.
But there's more to it than just writing the paper. You see, there's a bunch of code that's associated with it. So like you could have Python scripts which are associated with which actually generate the data and even the graphs.
So we've always been asking for we want the GitHub repository there. So we will take the version used in the paper. So we're even doing this with GigaScience. The version of the used in the paper, we'll take a snapshot of that because somebody could delete the GitHub repository, right? So we always ensure that whatever version was used in the paper, there's a permanent archive of that. If they've used Jupyter Notebooks, we'll link those in. If there's like something in Docker Hub, we'll stick that link in and stuff like that. But this new journal will be, the paper will almost be, couldn't potentially have versions, and you can fork things as well, right? Like, so somebody else in theory could take somebody else's research and then adapt, and you've got a fork, right? But
okay, so you're adopting the typical open source software model to this approach, and of course this means you need certain licenses.
But everything is openly licensed. So GigaByte, and so you see the logo. We've actually got a fork.
The marketing coming through.
Yeah. So we've actually stuck a fork in the logo.
This is cool. Research, release, fork, update, repeat, rinse and repeat.
Yeah. So this is the whole concept of it, right? And so this is.
I like this a lot. So how do you handle licenses?
So we just default. So
for what? Is it share and share alike?
So narrative content CC BY as
but there's different,
default.
There's
so software then. So if we're publishing software, so data we insist that it has to be CC0, right? So complete public domain waiver, no legal requirement for attribution, but it's attribution is never a legal thing anyway, right? If somebody doesn't, it's a gentleman's agreement, but there is a problem. So the recommendation for research data is CC0 is the dream, right? This is the best thing because there is a potential issue with attribution stacking, right? So as data sets are combined, and you combine data set upon data set upon data set, you will eventually lose track of small parts of it. And just CC0, you'll try to attribute as long as you can, but it may break down, and that's fine. And at that point, once it's so stacked, then you're such a tiny part of it doesn't even matter. So data we default CC, so narrative CC BY, data CC0, and then if we're publishing software, it just has to be under a OSI license. We don't like, most people are doing GPL 2, 3. MIT are the most popular ones.
Can you mandate a particular license and just say that's the way it is?
So, this is with great power comes great responsibility, right? We're a carrot, right? You get something, and so we have the power to do this. And if someone's pissed off, that's fine. There's another 19,999 journals they can go to. But if you want to come with us, our selling point is we don't back down,
we all love to sort of bike shed licenses, but I think maybe using the Mozilla public license V2 might be a good way forward, because in this way it's a share and share alike license like the GPL, except it's file level, which means that you can actually incorporate the software into your let's say your business, you're running a business, you can incorporate it into your proprietary work.
Yeah.
And the share and share alike does not propagate into the proprietary work, your closed source stuff. But if you make any changes to that code, then it would be expected to release those changes.
Yeah.
And the same works with you can actually include MPL projects into other open source licenses, like GPLs, etc., like that. So it's a very it's also a very hacker friendly license, and it's a very business friendly license. So you mix both worlds together very nicely.
Because I think the Mozilla license are OSI approved licenses.
Oh, definitely. Absolutely.
So we haven't drilled in more than we just say as long. We tried to be kind of just agnostic and just gone like just do an OSI one. So our own code, everything that we've been building, all of the GigaScience code is GPL.
Oh, dude, it's actually open source.
Yeah, we have to like eat our own dog food.
I was going to wonder, shall I ask this question or not?
No, we have to. We're pushing people to be open and transparent and everything like that. So we have to do the same thing ourselves. So yeah.
So would you say this is one of the first journals which have actually pushed the envelope so far?
I'd like to say,
All right, you can puff out your chest a bit.
Yeah. There's been, so there's a few cool. The big trad publishers have then done sort of. They've all launched their own kind of data. Elsevier has one. Springer Nature has a data journal. They all kind of we didn't invent the data journal. There's been subject specific ones. They're like environmental, earth sciences have been a layer of community. They've been sharing stuff for a long time, but a kind of general broad purpose one, we launched in 2012. Springer Nature launched their one in 2014. Elsevier in 2015. On the data side, there's been other people have tried to do similar things, but maybe not as openly. Software, there has been cool stuff in software. There's a journal and our hands have been tied because we're stuck with all of this legacy infrastructure and publishing and stuff. There's a journal called JOS, Journal of Open Source Software. Very cool. And because they've done everything in GitHub and their costs have been like super, super low. And it's all been run by volunteers. GigaScience has had to pay my salary, right? This is my full-time job. I'm more expensive. They've done everything themselves. Also getting grants from I think Mozilla and things like that. The thing that I've thought was most cool is that they actually have worked the editors are bots. So yeah.
Oh really? Okay, expand.
So just a lot of the standard. Hey, you've submitted your paper.
Okay. So the GitHub bots basically. Saying okay,
they've automated
I will guide you through
so
this process.
so much of it, and have you done X, Y, Z? Even so, they get humans to do peer review, but they're using they're doing it in Git. They're issuing, pull requests and back and forth because it's all in Git. It's super super cool. And
so they got GitHub bots, but as soon as GitHub, they're owned by Microsoft. At some point, they could just sort of flip a switch and
So actually, they are a bit. That's one thing that people have raised, but
still, it's pushing the envelope. It's showing what can be done. And recreating that model kind of thing, maybe in GitLab or something like that. Git tier. Fascinating stuff.
So there's stuff. We're kind of. There's a rebel alliance brewing that we're all kind of gonna try to take down the Death Star. So,
more power to you, geez. More power to you. How would you foresee? This is something I think about at night sometimes. How would you foresee a healthy society with a funding model that actually works for science? Like in the ideal world kind of thing. So what would it look like?
I'm biased, but more is, or we do need. So it's interesting. Some societies obviously spend more money than others. Like the Singapore Japan, some country, Korea, they spend up to 3% of their GDP on research, right? And like that's good, right? Obviously, you can't spend 100% of your GDP on it, but like 3% is a nice number. They kind of realize it boosts the, it has a benefit for society, and cool things come out of this, like tech and you're diversifying your economy. Look, Hong Kong, on the other hand, was supposedly a developed nation. This is one of my bugbears. The R&D spend here was about 0.7%, right? Which is the equivalent, same amount that North African countries are paying.
It's an absolute joke.
It's an absolute joke. So Carrie Lam, in her last budget, when she first came in and in her big budget, first budget address, she's doubling research spending.
Whoa!
So which is good. In 5 years, right? The plan is to double research spending, which is that it's long overdue, right? Nobody has done this before, but doubling would take us from North African levels of spending to Malaysia, right? So our dream, Hong Kong's dream, is to one day catch up with Malaysia in research spending, right? This is the dream. One day it's going to happen.
We'll do it, man.
Right,
we'll do it. Malaysia levels.
Yeah. So that's the anyway. So obviously more money is good, right? And then actually, and that's just another problem here. Then you do with great power comes great responsibility, right? So beyond bail dole, right? Beyond, and the key thing is we want to
So how do you
IPify, but the funders, and this is the European funders. So there's this Plan S, for example, that the major European funders have all come to. So by next year, the plan is that they will not. Basically, you won't get your grants renewed if you publish your stuff in a closed access journal, right? And North America hasn't really signed on to this. Asia's way off, right? Way off this. But most of the European funders, and it is driven by Wellcome Trust and the people who are pushing data share, made the Human Genome Project open and stuff like this. They've been focused on all of the focused on the publications first, but also the data. And so this is so modern, forward-thinking countries are fund it well enough, and also the point is this is for the public good, right? However much the researchers want to keep this data, it doesn't belong to them. It belongs to all of us. And so maybe you can write things in that they get a 1 year head start on the data they produce or something like that. But there has to be, by the end of this project, where is it, right? I want it publicly available. They're building a big open science cloud that the data has to be in the public, the narrative outputs need to be open and everything. And so focused on the outputs are open, not patented and things like that.
How much influence do you and your circle have in being able to influence this sort of outcome?
So we, on a small scale, we're a carrot as well, right? You play the game, you get indexed in these ways, you become an attractive thing to go on someone's CV. We can influence in that extent. The big journals they've got a lot more. They have a lot more clout. They go to they go to policy meetings. They meet the politicians.
So Carrie Lam et al. will be like,
So in Europe, the European Union, European Commission and stuff are very much there has been pushback. So Elsevier, they're a Dutch. They're a Dutch. There's going to be some bias in Europe, okay, they are a European company, and they're but then there's been a lot of pushback as well, that a lot of the policy people are I'm not working with these people.
They're Satan incarnate.
And the University of California, big groups of universities, big funders pushing back. Gates Foundation has been very early and signing on to if you get a Gates Foundation grant, it's big money, but it's not your data, it's everyone's data. You won't get Chan Zuckerberg, interesting. Zuckerberg's a lot can be said about Zuckerberg, but he's thrown a lot of money on he set up his own sort of Gates Foundation-y thing. But they're interesting. A lot of their focus is front-loaded on a lot of their money is changing academia, the incentive systems. They've been funding preprint servers. They've been funding a lot on their infrastructure side to try and make these cultural changes, which is probably one of the only good legacies to come from Facebook. So you can definitely see.
Wasn't there a list of about 100 or 1,000 academics that sort of put their name on a list of on a paper and in rebellion towards what Zuckerberg is doing about something? I didn't really. What was that about?
Yeah, so that was all Chan Zuckerberg funded scientists shaking their fists, but not actually saying, I'm going to give my money back. Because of this was all Facebook refusing to Twitter. A lot of the crazy shit Trump has been saying, like Black Lives Matter, instigating. So Twitter put this is hate speech, kind of has been putting hate speech, and taking some Trump stuff down, but Facebook has refused to, and Facebook has also said that they will not fact check political advertising and stuff like that. So anyway, I think that letter was academics all condemning Facebook.
Okay, all right, okay.
But they were all Chan Zuckerberg funded. They were funded by him, and they were saying we're not happy, but they still all taking his money.
Yeah, I see.
So it was a little bit of a funny letter.
Right. Okay. Well, we can move on from that particular subject.
Yeah.
This has been fascinating. Absolutely fascinating. If people want to contact you, how do they get hold of you?
I'm quite easy to Google and find online, and Scott at gigasciencejournal.com is my email address, and you can find me on if you look up GigaScience and stuff, there are email details and things on that.
Do you have any other sort of things you want to get out into the world? Any sort?
There's lots of things, but it's probably a bit late in the evening we've talked a lot on.
We have.
Yeah.
We have. We can probably wrap it up then.
Okay, yeah.
Scott, thank you so much for doing this. I really appreciate it.
Yeah, thank you for letting me come and drink oolong tea and ramble. Yeah.
Ramble on about the misgivings of science and troubles with science. Appreciate it. Okay.
All right.
We've been going for about 2 hours and 40 minutes.
Yeah, I'm getting a bit...
Yeah, I can see it.
Flagging.
All right.